Awesome sauce. So have fun, everyone.
Thank you, thank you, thank you. Yeah, so if anybody has any questions, feel free about NgRx in general or any state management things. Feel free to drop it in the chat there in Slack or in the YouTube chat. I think I'm tracking both. Yeah, and I'll be happy to answer them. All right, so the topic today is rethinking state in Angular applications. And this is one of the topics that I'm very passionate about, anything state related, state flows within the applications. I've spent numerous hours and, working through this. And I feel like one of the things that we can all improve on is how we do the state management. So this talk will cover today. We'll cover the new slide. We'll start with looking what the state management in general is, like what is the state that we're trying to manage. Then we'll cover some of the patterns for state management, like behavior, like service with behavior subject or reactive services. Then I'll touch into the NgRx component store. This is the newest library from NgRx team. I'll go for some of the use cases of it, and finally we'll compare it with the existing NgRx store, global store solution, where to use which one and how do they compare. So before that, let me introduce myself. So I'm Alex Okrushko, the same on Twitter. This is where you can find me, by the way, at Alex Okrushko. Happy to connect, so send those requests. I'm currently working at Firebase at Google and been for a while, but now I'm actually transitioning to a new team in Cisco. So I'm going to be in the principal architect role at Cisco soon. So I'm part of the NgRx team, fantastic team who spends all this time in their evenings and nights to get you the NgRx libraries. I'm part of the, I'm organizing Angular Toronto as well. So if you have the talks that you want to share with the audience in Toronto, shoot me a message. This is actually where I'm from, so it's 1 o'clock of the day for me right now. And I'm also hanging out with the folks at in-depth.dev. I have some articles there too, so do check them out. But what is the problem we're trying to solve? Let's see this. So I really love this very famous quote from one and only Albert Einstein. And what he said was, synchronizing state within the application and the backends is one of the most complex tasks that developers have to solve. Well, you can probably realize that he was probably a little bit before the internet, so he didn't say quite that. But I'm sure if he was with today, this is what he would say about the state and state management. So what is this complex thing that we're trying to synchronize? What is this state management, and what are the libraries that are trying to solve it for us? What does it do? What is state? Where does it live? Well, there are multiple ways to put it, but I really like this one. Initially, I saw it from Victor Sopkin years ago. So the way he puts it is, we have a server and backend state, right? So this is one type of state. And then we have the web app. And then the web app state, we have a number of states that we are interested in right now. So we have a persistent state, URL state, we have client state, and local UI state. So those are the four. We have more, but this is the one that I'd like to draw your particular attention to today. So let's take a look at them one by one. What is it? So we have a persistent state. And this is the state that we get from the backend. This is the ones, we persist to the backend and get from the backend to our application. So this is all your network requests that are going in back and forth. Those are your JSON that you pass around. This is a persistent state, right? So this is one. The second one is the URL state. And this is the state of a URL. Very simple, right? Or sometimes also the router state is included in here. So where we have some data within the router as well. So this is the URL state. Next one is the client state. Client state is the state that's important within the scope of the application. So the application is aware of it, is business related, but it's not persistent to the backend. For example, which tab is open right now is not persistent to the backend, hopefully. Our backend doesn't know what it do. All right, so this is the client state, important within the scope of the application. And we also have the local UI state. And for example, this checkbox or slider has its own state that's passed into it. So very frequently, the local UI state is set through those inputs and outputs, so it's very encapsulated. But this button is only aware if it's on or off, or if the user interacts with it. It has no clue what it means in the global scope, if it's persisted or not, if it's part of the client state. But it's a local UI state there, it contains it. Moreover, we have a second button right underneath it, another enable, and each one have that state, and they each completely independent. So this is a local UI state. All right, so what the problem we're trying to solve? Well, apparently, as actually it appears to be, that synchronizing all of these states is one of the most complex tasks that we as developers have to solve. And you can think of it, right? So user opens a URL, right? That URL, for example, opens a particular tab. That tab starts doing some API calls. So we're getting the persistent state. That goes to the backend. Persistent state gets back. Then it's pushed into the components. Then that one, goes into the local UI state of the checkbox, and the checkbox is on or off, right? So there's a lot of synchronization going on, and there's a lot of points where this could fail, right? So this flow of data is something that we really have to think about as developers. All right, so let's get to Angular. Angular is very known to be an opinionated framework, right? We have a way how to handle route, right? We have a router. We have forms. We have what else? We have HTTP client. Like, we have a lot of things that Angular already provides us with. But is it really an opinionated one, right? Is there some pieces that it's kind of missing? And the way I see it is it's missing one of those state management parts. So yes, it tells you how to put the components together. However, I think one of the parts, it is the state management. And yes, it does provide you with the services, but I think that's not enough, especially in the complex applications that we work on today. So let me show you one of the examples, what I mean, and where the state management libraries can really help you. And I'd like to take this very simple example. So it's a 3-page application. This is the one that I go through my workshop. So this is a 3-page, again, very simple app. It has like a list of products that it can display to the user. Once you click on one of the products, you see the description, you see other details. You can add it to the cart. For example, you can rate it, and you can do other things to it. And finally, once you click to the cart, you have the contents of the cart. So this cart icon and cart page itself, right? So this is where you see the all the products that you added, the quantities of it. This is where you can remove, purchase, and all the other fun part. So again, the application itself is very simple, 3 pages, that's it. But even it already has a lot of things that could cause some trouble for us. And let's take a look at them. For example, let's start with the simplest thing we can find on this page is our cart icon component, right? It needs to display how many items we have in the cart. All it cares about is just getting the data and putting the number to it. How can we pass that data to the cart icon? Well, there are multiple ways we can do it. First of all, it has the state. It has the cart icons count state. It has the state, and it needs to show it. And it's a number, right? So in this case, it's a 4. So one way is to provide it through the input, right? So we have a container component that does some services, that gets some data and pushes it to this component, and it provides it. It'll be a very local UI state within component. But let's take a look at another example. Let's take a look at the one where the cart icon itself will request the data. So here's the cart service that will inject. And the cart icon count now is an observable number, right? So we'll have the cart service where we'll call the get cart products. And we'll get that array of the cart items. And then we'll pipe that array through a transformation function. And that function will take that array and reduce it to a single number, right? So reduce cart items to count, we'll reduce it to a single number. And it will be observable of number in the end. And that's all we need, right? That's all we need to show. That's all we need to show for the user. So let's take a look at that cart service. how it's structured. Well, the cart service here, it only injects HTTP client. And what the get cart product method does, it returns you an observable of those cart items. And what it does is it's basically a very thin wrapper around the HTTP client, right? So it calls the HTTP client get, it gets the observable back, it passes it back to the consumer, which is the cart icon component in this case. It does not have any state. So cart service is stateless. Very simple to work with, very easy to test. Stateless, right? No state. Cart service has no state. And this is what we call a pool-based system as well, right? Every time we need the data, we have to ask for it, we get the data back in an observable format. Okay, that's great. But then, you know, look, there's other parts of the page that also need that data. For example, our page, you know, the cart details page here needs also the data. It also needs those cart items that it wants to display. It needs to display this math book and other products that we have in the cart. So now we have, you know, two places where this data is needed. Let's take a look at the structure of this page. So we have our cart icon component, right? It's part of the header, right? So this we start building on top. Then we have all these products that we need to get somehow. And these products are part of the products page. And again, it's so oversimplified, right? But then the cart page itself is in the router outlet, because this is, you know, when we navigate from page to page, that's the part that's changing. The header stays the same. And in the end, all of it is one in the one app component, right? So we have kind of this structure of components. Let's pull it aside into more of a tree view here. And now we have a little interesting situation. Now our cart icon needs the data, needs those cart items array, and our cart page also needs that data. How can we provide that data? Well, one of the ways is, you know, we provide the data to some kind of common node, and then you just push it down to the components, right? But probably many of you right away say, oh, no, this is not a good example, right? This is what we call property drilling. This is just passing data downstream, and this creates a lot more problems than it solves. Now the header is passing the data that it doesn't even need. Moving things around, inserting components in between, it's now a pure nightmare, right? So it has so many drawbacks that I'm not going to list all of them. So what we want to have is we want to have cart service, right, that provides the data to both of them. So we'll inject that and we'll be providing, each one reads that data. But then what we have is cart icon gets this data and cart page gets this data. So we're duplicating network calls, right? We're duplicating that get product details, get product lists calls, right? How can we solve that? Well, one of the solutions is to push it out to the reactive property. For example, in this case, we have the cart items $, and $sign means it's an observable, right? This is our convention. And then it will go and get the cart products and share replay them. And again, this share replay is safe in this case because service is provided en route, so we don't care about the number of subscribers. So it's always there. It always keeps it alive. So now we have this cart items that we can, you know, share among other consumers. Now our cart service becomes stateful. It now has a state, right? It used to be no state. Now it has state. And state, you know, makes things complicated. All right, so how our icon component changes? So instead of asking for the get cart products now, we can just, you know, listen for this reactive property. When it has the data, we'll just push this data in. Great, so now we are reduced this network request to a single one, and both pages are happy and they'll get the data. The first one will request, the second one will get that shared data. Awesome. Or is it awesome? Let's see other problem. That data that we have, the cart products, is not static. It can be changed within the application. There are multiple things you can do. You can remove items, purchase, remove all, or even add to the cart. They all affect that state. So it's not static, this state is dynamic. So we can't just read from it once and forget about it. So what can we do? What we want to do is to still have this reactive property, because it's nice, because we can really, not know what exactly changed the thing, but the changes will propagate to the cart icon. For example, was the cart item, added? Was it removed? Cart icon component doesn't care about if the products were added or removed. All it cares is that the number changes, right? So it starts listening for that observable, the cart items $sign. And then the constructor, it says that, hey, I'm interested in this data. So it sends this signal, get cart item products. This is what it wants to do. So we created here an indirection, right? So we're no longer reading from this data. We're now listening for the reactive property, but sending the signal as well. So we have this indirection. Okay. Let's see how our cart service is changing now. Well, for that, we'll put something called a behavior subject. So we'll have this cart item subject as a private subject that will be a container of this reactive state. And in this case, it's a behavior subject of cart items, and we need to pass the initial data there, so the empty array. So our cart service is still stateful, and it will keep that state inside. For any consumers outside, it can expose it as an observable. So read-only cart items $sign is an observable. So when we do the subject as observable, we're trimming the observer APIs from it, so we can no longer next into the subject. So we can no longer do that. And this way we encapsulate the changes to the data only within the service, which is great. That's what we want. So how can we do that? So for example, now, whenever we need to add a product, we can call this method. And this method, notice, is returning void. So it's basically a signal to this service that we want to do something. And internally, it will call the HTTP, it will subscribe, and then once we get this data, it'll push it into this cart item subject. So this is how the subject will get the data, and observable will get that as well. So this is the way for us to now use it as a signal. All right, so let's see how we're consuming it. Well, we are reading this cart item still, right? We're reading this property. It's providing those observable values to us. Every time somebody changes, be it adding the product, removing the product, or something else, or even getting the product altogether, it will change that data, and our cart icon would react to it without knowing who exactly affected the change. So, but that's really nice, right? We don't want to know who did this. All we know, and what we need to know, the cart icon component, is that somebody did that. Great. So it appears to work. We're very close now. We can listen for the data from one thing. We can add and remove. Looks like we got it, right? That's the approach that we had. Was called the service with the behavior subject, or some call it observable service, some call it reactive service. It's all the same thing underneath. It's basically this version of the implementation. All right, but it still has a problem. Notice the add product there. Whenever we call it, say we have a very happy user who really wants to add a lot of our products. So the user goes click, click, click that button multiple times. Each add product call will result into the network request, right? And more interesting, they're all in parallel. So for example, the first time we click that button, for example, of send its add product, it starts a request. And then the second one can click. But the thing is, with network requests, we have any guarantees what would be the return order, right? It could happen that the second request arrives before the first one. And this is what we call the race conditions. And we have a solution for that. Effects. Effects are the ones for controlling the race condition. And the behavior subject that we have there, it kind of has this drawback because it doesn't control the race conditions. Everything is basically sent at the same time whenever you hit that. All right, so for that, we have a component store. component store is an interesting thing. It can replace your behavior subjects, services with behavior subjects, but it can do even more things. And what's interesting, this new library, component store, is basically a single file with 350 lines of code. And let me repeat that. A single file, 350 lines of code. Super lightweight, super lightweight. And then it has a few additional operators that you can use. So, and it's completely independent from the global store. So if you were saying, hey, I don't like that action, this one doesn't have the action. But they're both good and they both have their benefits. All right, so component store is a state management library, standalone, completely by itself. And just like any other state management library, it needs to do three things very well. It needs to be able to read the data, it needs to be able to write the data, and it needs to be able to handle those side effects. All right, so we have a select for reading, updater for writing, and we have effect for the side effect. Let's take a quick example of one of them. So if we were rewriting the stateful card service, that the one that had the behavior subject, it will kind of look like this. So first we'll identify the state, and we'll have an interface for it. So in this case, card item, right? So this card state will have the card items. Then we'll extend the component store, right? We'll have a service. This card store is a service provided in root in this case. It will extend the component store, and this is where we'll pass this interface to as a generic. So we'll know that it's responsible for this state. Then we'll, in a constructor, inject any dependencies that we need. And in this case, we're injecting the card service. But again, we're taking that card service back to its original roots, completely stateless. It's just wraparound HTTP calls, right? So when you call a thing, you call get products, it gives you an observable. Very, very simple, no state. Because our card store will be responsible for the state itself. Now, we need to initialize the component store at some point. In this case, we do it right away in the constructor, but it could be done lazily as well. All right, so let's now move to the read. So now we need to read the state out of it. To read the state, we have a select method. And in this select method, we take a state and we tell it what exactly we need to extract from the state. And in this case, we're extracting card items. Very simple. What's interesting is this select returns us an observable. So card items here is already observable of those card item array, right? So it's an observable. But select is more powerful than that. It can also take an observable and listen to that and do other transformations. For example, here the card items count, right? That observable number. It takes an observable, or it can take multiple, and then we'll use this function here to reduce those card items to a single number, right? So it's basically a function. And now we have an observable that will be providing us with those items. Whenever they change, the count change, we have an observable that emits those values. So this is how we can select. And select is really powerful underneath. First of all, it does all this distinct until change, so you don't get duplicate data re-emitted, right? So it emits only when the data really changes, right? It has the share replays and all the things underneath, so it does the multicasting, so you don't have to worry about this, of missing the data at some point. So it does all those good things. And moreover, it also will unsubscribe when the component store is destroyed. We'll get to that in a second. All right, so we have a way to read the data. Now let's write the data. And by the way, here's how we read. This is how we use the component store for reading the data in, for example, our card icon. So you inject it just like any other service, right? You can even call it card service if you want to, but again, this is a card store. I like this store suffix as a convention. So you can inject it just like any other service and continue to listen to the data from this card items observable. That's it. Now, when the data is changing, our card item reacts. It's all push the data with a sync pipe into the template, everything happy, everything's reactive, everything works. Okay. Now let's move on to the updating, how we update the state. For updating the state, we have this function called updater. And then function takes a few things. First of all, it takes the state, right? The current state that we have in the component store. And second argument, it takes a value. For example, in this case, cart items. And then what it would do, this arrow function needs to return a new state immutably, changing it, right? So we can spread the previous state and replace the cart items property, for example. So this is updater. So set cart items is now a property here, but this property is a callable property. You can think of it as a method. So you can see at the bottom there, we do this set cart items and we pass the value into this. The value that we pass into it is actually this value that goes as the second argument of this arrow function in the updater. So this is how we call it. It's really almost, it feels like a method, right? Just like service method. That's how it feels when you consume it. Great. And the final piece, one of the most important pieces, is this effect. And what effect does, it also returns you this callable property. So add product is, again, callable property. You can think of it as a method, right? Which takes a value, and that value, those values are pushed into this IDs stream, right? So the IDs observable is where it's pushed. So every time somebody calls the add product with a single ID, it's pushed into this stream, right? So here it is, this IDs stream. And now here, we can really handle these error conditions. We can really be smart about it, how we want to handle those race conditions. And we remove any of that implicit complexity or incidental complexity. Complexity just happens by accident. And to be very explicit about it, how do we want to handle it in real race conditions? For example, in this case, I'm using a concat map. And concat map is a high order operator that takes a value, right? And then here, our cart service add product, we pass ID, it will return an observable back, right? And we will know how to flatten it back into the mainstream, all right? So concat map can help you deal with the stream of IDs and call the services to add the product one by one. So here you can use one of those four operators that are handling this race conditions for flattening operators. Concat map, switch map, exhaust map, and merge map. And they all do different things, right? This is how they handle it. For example, concat map, when you get the first ID, right, it calls to add the product, right? It calls the service, and it starts working on it. Then the second ID comes in, and it's still working on the first one. What it does, it queues them up. It says, okay, wait a second, I'm still busy with this one. Once it's done, right, then it will take the next one. On the opposite hand, we could use a switch map. And switch map acts the following way. You have one ID, it starts working. You have a second ID coming in, right? And what switch map does is like, okay, whatever I was working on, discard that and start it with a new ID, right? This is obviously not what you want to use for editing the product, but this is one of the options that you have. Then you can have exhaust map, and that one will do things a little bit differently. If it gets the first ID, it starts working, and then it gets a second ID, it says, okay, I'm already working on it. Don't worry, and just discards this incoming value until it's working on the first one, right? It's useful when you're trying to get the data, when multiple things asking, hey, give me the data, give me the data, give me the data. You can just say, oh, I'm already getting you the data. I just need it once, right? So I'm still busy. And the final one is the merge map. That one starts things in parallel. So every time there's a new ID, it started in parallel. Merge map is how our service with behavior subject basically works, but without us having control over it, right? Here, we can really be in control and saying and being very explicit which of the strategies we want to use. So I use concat map in this example. All right, now once we have the data, right, we add the product, we have the data back, we have this inner pipe. And within this inner pipe, we'll do a few things. We'll use a tap operator, and then what we'll do is on next, when it's successful, we have these new cart items that we just we got from the backend. We'll use this updater, the set cart items, and pass this value to it on the next. On the error, we'll do something else. For example, in this case, we could have called another updater to set the status for error, something like that. But it's very important that we handle the error. And lastly, because we want this stream to not collapse if there is an error, we need to catch the error and basically do it to empty. And moreover, so this was such a frequent thing that we do. We call it the backend the tap and catch error. It was tap and catch error, tap with next and error, and then the catch error. It was so frequent that we decided to have even less code and just had a very small operator that basically combines those two into one. We called it a tap response. And the tap response, again, just takes 2 arguments. It can take 3, but it takes at least 2. First one is on a success. Second one is on error. And the on error one is not optional. And the reason why is I really like people to handle the errors. But you don't need to have a catch error in this case because that's what tap response does inside. So this operator comes with NgRx version, I think 11. So that should be within a few weeks. We release that. All right, so now how we would use this effect. And again, we inject this cart store in the service, just like we do anything else. And we have a method, add to cart, and it takes the product ID as a string, a single one, right? And we call this effect basically as a method, right? Just like a regular service method, cart store, add product, and we're passing that single value to it, right? Every time that callback is called within the component, it will push the new ID. And then those IDs are pushed within this ID string. And this is where we handle the race conditions. So it's a very neat way to handle all of these race conditions and make sure that your how is pushed into the component store, and the component itself becomes really, really simple. All it does, it just calls those methods on the store and maybe reads some data from it. They become really simple, really easy to test as well. All right, so this is what we had before. So cart service was double requests. Now we have a cart store that's provided in root in this case, and now it could be injected in both of these components, and one can read the data or add, remove, whatever it needs to do with it. Here's how they compare, right? So on the left side, we had the cart service that was stateful, right? With all the things there, but it had no error handling, and it wasn't handling the error conditions, right? And I don't know about you, but I feel already, worn out of seeing those infinite spinners when something error happens on the websites, and well, it wasn't handled by the team somewhere. Anyhow, those are the things that we really want to bring to your attention and ask you to really handle that. All right, so where else could you use the component store? Well, we saw the provided in root use case. I could be used in the complex independent component state. It could be used as a reactive local UI state and shared common component state. Let's get to those one by one. So we just saw the provided in root case. And even though you see the warning sign there, exclamation mark, it kind of works, but then if you have too many component stores that have now become provided in root, you now have 10, 15 of those services all around, each with their own state, start injecting one into another. Now that becomes, again, the mess that we're trying to get rid of, right? This is the mess that we were really trying hard to solve with the NgRx store and other ways, right? Because we feel this is too much, right? And in the end, a state becomes all over, and it becomes a service soup, I call, right? It's spaghetti code, but it's a service soup because you lose control over that very fast. There could be a good use case for the provider in root, and the good use case that I typically provide is the permissions. The user permissions, again, it's a very small state. it's truly global, but it's very, very narrow. Like there's no, the chances that you'll have other services injecting that, almost none, right? So that one's a small one. And that one's probably an okay use case. What I really like where this shines as the star is complex and dependent component state. And what does it mean by that? Well, it's kind of a similar picture of what we had before, but in this case, component A is providing the cart store. So in the component providers, in the component metadata, in the providers, it provides this cart store, right? And what it does, it now links that component store, the cart store in this case, to the life cycle of the component A. Meaning, if component A gets destroyed, cart store gets cleaned up, everything is automatically unsubscribes, effects are stopped, everything is cleaned up, and now we can move on to something else. So for example, user move to some other page, right? So you don't need the state anymore. All right. So, and they can still inject them into the C and E, and each one will get the proper instance because that's how a component injector hierarchy works, right? The C, they'll go to the B and D, and they find it at the A level. All right, so this is a really good use case, and this is, we've been using component store on the Firebase team for almost a year now, and this is one of the examples that really stood out. The other one is a reactive local UI state. So if we get back to this one, component B could be really heavy on the business logic within the component, and would like to offload it somewhere and make it a reactive way to do it. So we can provide a component for B that is providing, has like a local store provider, and it's also injecting it. So it's not designed for any other components. It's literally for component B only, but you are separating all the business logic into it now. So component B becomes very easy to read and test, right? Our test bed tests, we don't have to write a lot of them because we basically make sure that, hey, this is the inputs and you see them in a template, and you do something on the template, they call some store, right? So this is basically what you need to test. And then you can test local store in detail separately outside of it. So that makes B easier to read, removes the business logic, and all those great things to it. So this is a reactive local UI state, which is another major use case that we identified. And last one, shared or common component state. That's also, I put the star in there because that's example that's how component store was created to begin with. This is the use case that drove it across the line to actually get there. And this is a very typical use case. So we have an app, right? We have component A, and we have a common component. And this common component could be, multiple pages. It could be even on the same page multiple times. For example, we have a graphs, right? And graphs could be complicated. And they interact with the container component A through them inputs and maybe outputs, right? So they get the input, they can do the things to it. So this is how they interact. And there could be many of those common components. For example, here's 2, right? And each one through the input or output. And in this case, we like the reactivity. We like those reactive stores. And people were asking, who were using the global NgRx store, asking, how can I put this common component state into NgRx global? And the typical answer would be, well, you can sort of index it by something and inject it there. But then what you end up doing is you end up pulling this state out of common component. It's completely encapsulated into the shared state, which has no business of doing there. Like it's not designed for it. It's just not devoted. It only needed within the component. So the answer here is you can then have a common store that is provided in the common component and injected in there, for example. And each of the common components, each instance will get its own independent store. Like this is what we have with those providers that we use on the component level, right? So there's providers in the component in metadata, which means that we'll have that service instance for each of them. And then Now that state can be used in first, second level children or anywhere else within that group. And moreover, if one of those children are injecting the common store, they'll go up the hierarchy in the injector hierarchy, and they will get to the common one, and they'll find this common store, right? So each one will be using its own, which is really great. Okay, so this is one really pushed us to create this component store. So how does it compare to the global store, for example? Well, in global store, for example, on this page, we can have a rating that's rated by the customer, right? So the customer, and this will be a different color. So if I, for example, rated this product, I want to see my rating. I don't want to see the average rating, for example. So we could have this this component that now reads all the customer ratings, the custom ones, right? And reads all the products, injects a rating store, rejects a product store, asks customer ratings, asks for products. So it kind of works with two. If you have more services, you can see where it's going. It's, starts to flooding it. And the global store, the role of it is to inverse that logic, reverse that responsibility from the component to the system itself. What the global store does is it dispatches the action, right? And then this action, for example, in this case, that product list component, page is open. It dispatches it. And then each effect or reducer can independently be triggered with this component, by this action. For example, ratings will start fetching the ratings, products will start fetching the products, and then selectors will aggregate the data and provide it to a single view model for this component. So you're basically reversing the responsibility, you're putting that responsibility somewhere else outside of the component, which is quite a nice way to do it. It's also easy to test. So this is where NgRx global store could be more beneficial, for example. There are other use cases as well where it's more beneficial. For example, the dev tools are only available in the NgRx global store. There's no dev tools for the component store. All right, so here it is. And for those of you who are not aware how global store works, what people typically call NgRx, which is NgRx store, is it has these actions that we are dispatching, right? And these actions are an extra layer of indirection. We already had one layer where we were reactively listening for things and notifying with those messages somehow, calling those methods, which were basically triggers. But this one is an extra layer because now action can really, dispatch multiple things and trigger multiple things at the same time. This is typical structure of the global store where we have a single store. We have multiple reducers who could be listening for the store. And those reducers are listening for these actions, right, that are being dispatched from all over. Components are dispatching those actions, right? They are consuming the state using those selectors. And then those actions also trigger the effects. They could do the synchronous stuff, for example, method requests. They, in their turn, produce other actions, and they all go into this common stream of actions, which could trigger other reducers, other effects, or not do at all, nothing at all. All right, so let's see how it compares to the NgRx Global Store APIs. So we have those create selectors, create reducers, and create effects. So you can see it's very similar in that sense. What's different, though, is in the global store, selectors, reducers, and effects, they all can live in their own files. They do live in their own files typically. And that scales really well because should you have more selectors, you just create a separate file and put them there. If you have more reducers, you split them somewhere outside. And again, same with the effects, you can create just another class for effects. With the component store, it's in the same file. It's a single file, right? It could be multiple instances of a component stores, but each one takes now the whole responsibility for selecting, updating, and producing those effects, right? So this is the bigger difference. I can have some additional selectors as well, which I'm going to touch right now. Then the state itself, NgRx store is a single, shared common object, right? So it's a single state. There are multiple reducers that each touch their own slice of state. That's true. But it's still, at the end of the day, it's one single object. With the component store, they're all multiple independent states. And independent is also key because they should be really independent, right? They should be each taking its own responsibility. And the other bigger difference is NgRx store lives for the lifetime of the application, right? So it's always there. If you need to clean it up somehow, there are actions to clean up. But anyhow, it lives the entire life cycle. And component store, it could be for the life cycle, but most of the use cases, and it's really designed for to live within the lifetime of the containing component. Right? This is a bigger difference. Meaning it cleaned up, when component store is destroyed. When component is destroyed, component store is destroyed, and it's cleaned up. All right, so some summary here. Synchronizing the state is a complex task. And especially if you have multiple moving pieces, multiple things can change the state. If that state is consuming multiple components, it could be a complex task, right? And state management libraries help to remove this incidental complexity. The complexity that just comes, is hidden within our services, maybe services with behavior subjects. They're just hidden. We want to expose that complexity, bring it up to you, and so you can make the decision, opinionated structure, the decision how you want to handle the race conditions, and we're really asking you to handle the errors as well, right? So this is how the state management libraries really help you there. And NgRx to the rescue in both of them, right? We had only the global store. We have the component store now since August. It's production ready. It's ready to use. So please do use it. And if before, NgRx store was for some type of applications, maybe not for all, this component store, I think, can fit all the use cases for even small applications. Moreover, the two can work together quite well, right? So the global one and the component store can work well together. So you can use both, like we do it, for example, at Firebase console right now. Yeah, so there you go. And I also wanted to say thank you for a few people who helped create this. Kevin Yelko is a teammate from Firebase who originally created the component store within Firebase, identifying the need. Brendan and Tim from NgRx team, so they did a lot of reviews, back and forth discussions about it. Nicholas Jameson from RxJS team, he helped create one of the custom operators that we use in component store. And Lars also spent lots of hours with me discussing some of the things about the component store. So thank you for those people who put a lot of effort into it. You can read about the component store at the NgRx.io site. So we have guides there. So component store has its own space there as well. So you can read it there. And one last thing I wanted to mention, the Discords. So we have Discords. The first one is the official Angular Discord. This is where, chat is where Angular team is there, GDEs are there, library authors are there, many other talented developers are there. So a lot of lively discussions, really great place. I think it's over 4,000 people there now. So join there if you're, it'd be a really cool place to chat. And then there's also one dedicated for NgRx. Like in the Angular one, we do have NgRx channel, but we also have a dedicated NgRx Discord if you want to go in depth for some of the questions about the NgRx. So join that one too if you can. And that's pretty much it from me. Thank you so much. I'll be happy to answer any of the questions if you have any.
Well, I think we had just one. First of all, thank you so much for that session. It was amazing. I think we just had one question about NgRx 11.
NgRx 11, yeah. So NgRx 11, we tried to keep NgRx versions close to Angular ones. So for example, Angular 11 was released like about half a month ago. We tried to, within the month, to release a version that would be like 100% compatible with it. So right now we're working on it. We have a few things we want to get in. So those are last minute changes, last minute adjustments. So we do want to get it in sooner. But actually, I've been using NgRx 10 with NgRx 11, and it still works. So there you go. That one still works, but 11's too soon. Yes, soon.
Great. So I'm also imagining there's some questions maybe in the Slack channel that may have popped up. And yeah, I think that's it. Thank you so much. And thank you everyone for joining us. That was our last session for the day. So join us tomorrow at 6 p.m. at Israel time. That's GMT +2. Don't forget to check out our sponsor booth. Don't forget to look all over their website for those secret passwords for the scavenger hunt. And thank you so much for everyone who joined us today. And again, thank you for amazing sponsors for helping us make these happen. Good night or good morning, I'm guessing, for you. Bye.
Good afternoon. Thank you. Bye.